Hi, this is Nat, and this is your video lesson on choosing the right graph for different sets of data. We've covered a lot of different graphs this unit, and one of the biggest things that students struggle with after all that is figuring out what graph do I use when. And so we're going to talk about the different types we've seen and when you should actually use them so that you can hopefully make good decisions about that. Way back in the unit, we started off talking about line plots. And if you remember, a line plot is a graph that we make where we put little X's above the line to represent people who've answered a particular way to a question or who fit a particular data type. So the big thing to know about line plots is use it when you're collecting data. It is a great way to get a quick graph made. It's not the best graph, we don't love it, but if you're just trying to get a really fast comparison, a line plot's a pretty quick way to do that. You can collect data and graph at the same time. Another important thing to remember is that it's only for frequencies. Every X on the line plot represents a person or a data point that fits that specific type, and so it's really good at showing frequencies, but pretty much nothing else. And for that reason, it's actually a graph we really don't use a whole lot. Probably not your go-to graph. A bar graph looks better, probably cleaner, can show all the same information and then some. So although it's good to know how to read a line plot and know what it can do, it's not one that you're going to use a whole lot. That brings us to a bar graph, which is probably, if you were thinking about making a line plot, a good alternative. It looks a little bit cleaner. You obviously can't do it as you go. You have to know how high those bars are going to go before you start making them. But a bar graph is a nice substitute. It does all the same things a line plot can do and then some. So use it when you want to show frequencies, just like you would a line plot. Always important to kind of remind ourselves that frequencies, though, are not data. So we don't do things like calculate the mean, median, mode, or range on frequencies. Just something to keep in mind. The advantage of a bar graph is you can use it for not just showing frequencies, but also for comparison. Bar graphs are really good at letting us see the difference visually between two sets of data or more. They show that very, very clearly, so they're very, very good for comparisons. And you can compare lots of different things. You can compare whole number data, you can compare fraction data, you can compare decimal data. Just a really versatile graph if you want to put two things next to each other and show how they're different. And speaking of comparison, a pie chart is another great graph you can use to compare things. A pie chart does a really good job of letting us see proportionally how many people or how many things take up a group. So a lot of the times when we could use a bar graph for something, we could also use a pie chart for it. And a lot of it depends on what we're trying to do. The big difference is that a pie chart is always parts of a whole. So how the parts of a whole group break down. The other thing to know is that when we're making a pie chart, the things that we're comparing are typically frequencies. So as an example, a bar graph might be best used for comparing the different heights of people in a class. It really lets us see the differences between people's heights. A pie chart would be really good for showing us the proportion of people in a class that were different heights. So saying this group are the people who are in the 5-foot range, and this group are the people in the 4-foot range, and really letting us see how people group up and what proportion of people are in each set. That said, anytime you could use a pie chart, you could probably also use a bar graph. So it's really important to think about, well, is my goal to show how the parts of a whole break down or not? If you're really trying to focus on parts of a bigger whole, then the pie chart's the right choice. If you're not, maybe use the bar graph instead. That brings us to stem and leaf plots. Stem and leaf plots are really good at organizing big piles of numerical data. So if what I care about is to just have all my data and have it organized and neatly displayed, then a stem and leaf plot might be the right choice. Also, because of the way that it's made, it's really good at comparing groups of tens. So for example, in the stem and leaf plot on the left here, I can see that the 20s was the most common set of numbers. It's also really good for easily pulling things like median, mode, range out of, just because the data is already really well organized. Generally though, if we're being honest, a stem and leaf plot is not a super common graph. But if all you have is a big list of whole number data and you want to display it somehow, the stem and leaf is really the only option. The line graph, not to be confused with the line plot, is used really specifically, and it's a common graph when you want to show how a single piece of data has changed over time. And that's really it. If you're looking at a data set and you see that you've been measuring one thing across some kind of time period, days, weeks, months, years, whatever, a line graph is pretty much always the way to go. It's super common because it's really good at doing that one thing. And finally, we have the scatter plot. The scatter plot is a fantastic graph to help us kind of discover relationships between things. It's important to recognize that it's only good for numerical data. But if you have two sets of numerical data from the same source, and you want to see if those data have any relationship to each other or a correlation to each other, setting up a scatter plot's a great way to do it. Definitely remember, though, when you're setting up a scatter plot, every dot represents the same person or the same thing. So basically it lets you see for that one person or thing what are two different numerical bits of information about that person or thing, and how do they relate to each other? Do they have a correlation when we look at a big group of individuals with those two bits of data? All right, so here's your practice for the lesson. You don't have to make any of these graphs, but you do have to say what type of graph you would make and why. So for number one, if you were going to make a graph to show the change, which is missing an E, to show the change in Bill's weight over 12 months, what sort of graph would you pick to show that? Same thing for number three. If you wanted to show the relationship between the amount of snowfall there was and how much time people spent watching TV, what graph would you pick to do it and why? Alrighty, good luck.